Hi. Thanks for sticking around till the very end. So yeah, basically, if you aren't here for this, thanks for coming anyway. We're going to be talking about Kubernetes operators using Java, go figure, and a bit of Spring Boot. So yeah, I'm Tiffany Jernigan. I've been doing developer advocacy, so things like this for a little bit of time. Currently looking for jobs, so if you're hiring for developer advocates or something related, please let me know. The QR code there is for basically all the links here, since most people aren't going to go type all of that up on your phone. But yeah, so my website, which has talks I've done before and things that are upcoming, if you still use Twitter or X, and then LinkedIn.
And I'm Ties van de Ven. I'm from the Netherlands, working at a company called Eleander, which is a Dutch power grid operator that operates about a third of the Dutch power grid. That doesn't exactly sound like a software engineering company, but in practice we have about 1,200 developers and 200 teams working on software there. And it's my job as a software quality expert to help improve the quality of the software within the company, which is a pretty cool job, and I get to call myself expert, which is pretty nice as well. So my background is in software engineering. I did that for about 15 years, mostly Java, Kotlin, even a bit of Scala, because I kind of like functional programming. And what I'm really passionate about is figuring out underlying concepts and underlying problems, and then sharing the knowledge about it. So here today, we're going to talk about the underlying concepts of Kubernetes, namely operators. So what will we talk about? We're going to talk a bit about what operators are. We take a bit of peek under the hood of how conceptually Kubernetes works. We're going to show some custom operators. And in the end, we're going to build our very own operator using Java and Spring. So first, what's an operator? Well, in the old days, when we didn't have those fancy cell phones yet, and actually had a physical phone you needed to dial, you couldn't actually directly call someone. First, you had to call the phone center, and some operator would pick up and ask you who you wanted to be connected to, and it will actually physically connect you by placing a plug to the other person. And this is what an operator does, like a raccoon buddy here. It receives information through a call, and then manually starts doing some work. In software engineering, we also had a similar thing going on for a while. As a consultant, at some point, I worked at the company, and after a sprint, I finished this nice jar, did tons of work, have a really nice application, and in order to deploy it, I actually had to call up a different team because I wasn't allowed to do so. And then I kind of had to hope things were going okay, otherwise I had to debug through this human console interface. It was not a good time. Luckily, these days, for this, we have Kubernetes.
So who here has used Kubernetes before? OK, so slowly going between half the room, 2/3, et cetera. But yeah, so because I live in the US, this is using feet. Go figure. But basically, at a very high level with Kubernetes, it's basically just like a big YAML database that happens to be running your containers inside of pods. So within Kubernetes, there's a bunch of controllers that are running, and these kind of behave as our operators. If you're wondering why the raccoon, I just like raccoons, so he included them. But yeah, basically, instead of calling up some sort of operator and being like, hey, I want this, you end up passing in YAML. So basically, this controller then, you have a desired state, you have your current state, it tries to get your current state to whatever that desired state is. So there's this concept of a control loop. So basically, this is actually what I was trying to do in my hotel room last night. It may or may not have worked. But basically, so my current state in the room, it was 24 degrees. A lot of you probably have dealt with dealing with temperatures. But basically, then the desired state, which I was trying to get to, was for 20. So basically, it is constantly watching. It keeps trying to get your current state to your desired state. Eventually, maybe you get to that point, and then maybe later it gets off again, and it'll try again until it's back to that again. So it's just constantly monitoring that. So within Kubernetes, since a lot of you, or most of you actually have already used it before, you probably are familiar with some of these. So these are actually built-in controllers with Kubernetes. So you have your deployments that ends up having a replica set. You have your daemon sets. You have stateful sets. There's jobs, et cetera. There's just basically a bunch of what you're dealing with in Kubernetes already. There's a controller behind that.
So yeah, how do these controllers actually work? Well, it all starts with sending YAML to the Kubernetes API. Typically, this is done using the kubectl command line tool, but these days there are tons of things like Helm or Customize or all kinds of tooling, but in the end, all the thing the tooling do is just send YAML to the Kubernetes API. So what's actually in this YAML that we're sending? Well, we see a number of fields here, starting with the API version. That consists of two parts, a batch and a v1. The batch is the group ID. This is the ID where the API underneath is hosted, and it's versioned by the version number. And we have a kind, in this case, cron job. And Kubernetes uses these three fields to determine which controller needs to pick up this specific resource. Then we have some metadata. Kubernetes uses this to store it under the correct name in etcd. And underneath, we have the spec, which contains a configuration for our specific controller, in our case, cron job. So what happens once we send this YAML? So we send it to the Kubernetes API, and the Kubernetes API will just store it in etcd, the database. Within the cluster, we have a bunch of controllers asking the Kubernetes API, are there any changes? And at some point, our cron job controller will see, oh, there's a change, the cluster is no longer in the desired state. And it will now attempt to make sure the cluster becomes in a desired state. If anything goes wrong, this doesn't really matter, because if an error is thrown, it's still in the reconciliation loop seeing, oh, the cluster is still not in the desired state, so I should just try again. So the whole retry mechanism is, in that sense, built into Kubernetes. It's also interesting to see how these controllers actually work. And this was my biggest insight when I got from researching this topic. Most controllers actually don't do a lot. Most controllers actually only do whatever the small thing they are supposed to do, and then offload all the work to the other controllers. So our cron job controller actually only needs to do some scheduling. It needs to make sure at a certain time a job is being executed. And it just sends YAML to the Kubernetes API for the job controller to pick up. It is exactly the same YAML as you or me would send via kubectl anyway. And the job controller doesn't do much more than just send YAML to the Kubernetes API telling the pod controller to do stuff. So most things controllers do is actually telling other controllers that they need to do stuff. But this is a very powerful concept, because this means that every single controller is the simplest possible thing it could be. And as we learned this morning, that's a very good strategy. And this makes it, there are building blocks, and because everything is built on top of each other, it's both easy understandable, but it's also very extendable. As in this allows
ones that you have there, maybe that does what you want. Maybe it doesn't. Then there's other ones that you could go on the internet, go look around for, and see what's already out there. So there's a blog that Josh Long did, which is actually quite a few years ago now. Time seems to kind of fly. But you can go there to take a look at some of the things that are there. There's a few examples there's Argo, which basically it will watch what's happening inside of a Git repository, and then changes will end up happening based on whether you make changes to your repository. There's Postgres, which will basically create a database for you and then put a password into a config map. There's one also for external secrets operator. There's just a bunch of different ones out there. So if you go to operatorhub.io, you can see a bunch of ones that other people or companies, et cetera, have gone and created. So perhaps that's maybe you have this question of, OK, I want some sort of functionality. OK, so then the first question is, can I do this by default in Kubernetes? If you can, well, then great. You don't actually need to go and create anything. Well, if you don't, then there's a question of, is there one that's already out there that exists that does what you need? Also, if there is, great. Don't need to create it again. But if in both cases the answer is no, it's not already there in Kubernetes, and also I can't find what I'm looking for, or I need something very specific for my use case, then that's where you need to come in and end up writing your own operator.
So what are good use cases to write your own operator? One of them is trying to automate complex tasks for teams. If I look at what we did with my own company, Eleander, we had this very complex authentication flow, where you had multiple moving parts, which all needed to be configured in the correct way. If it wasn't done so, it either wouldn't work or it wasn't secure. So one thing we could do is ask all 200 teams we have to just configure all these things within your pipeline and pray that all these 200 teams will do these things correctly. We could do that, or we could facilitate those teams and instead create an operator that does all these things for them. This way, the operator will make sure everything is being configured correctly, all the moving parts are made correctly, and all the teams have to do is just send some YAML to our operator, with only the things that are needed for their specific team. And in this way, 200 teams only have to do that instead of the whole authentication flow, which is a big win. So now the cluster can take care of these things instead of the teams. Another good reason to build an operator is for credential management. What if that workflow within the authentication flow requires you to, for example, create an account in Active Directory? Then you would need to have quite high-level credentials to communicate with Active Directory. You will give rights to every team in the company. And a lot of things can go wrong there. Teams can, again, misconfigure it. They can accidentally create too many users, delete too many users, or even worse, credentials can leak, because now 200 teams have access to these credentials. So instead of giving all these teams these credentials, what we could do is put them in an operator. So now only the operator and the team building the operator have access to the credentials, and the rest of the company can only talk to that specific operator and only do actions that that operator permits them to do. So it's a good way to keep all the credentials away from teams. And of course, there are also some pitfalls in creating operators. My company had identified these two, where first of all, operators can get out of sync. If something for some reason goes wrong with an event or something not being processed, the operator might not know what the current state needs to be anymore. Or in our case, we had an operator that was watching some resources outside of the cluster and therefore didn't really keep it up in sync. Luckily, this was easily fixable. Maybe you're familiar with saying, have you tried turning it off and on again? Well, basically, that's all you have to do. If you restart the operator, it will resync with the cluster, and everything is OK again. So if you have these kind of operators, just make sure you turn them off and on again, or programmatically do that. And the other one is ownership. Every resource within Kubernetes should be owned by a single controller. Because if multiple controllers try to do things with the same resource at the same time, yeah, weird stuff can happen. Same with programming. If you're in a multi-threaded environment, if multiple threads start tampering with the same resource, weird stuff can happen. So we want to try to avoid that. And a good way to avoid that is the operated chaining pattern we saw before. Instead of doing everything yourself, you just call other operators to do things and let them own that bit of the resources. Don't do that yourself. So those are two things that we had trouble with at Alliander while creating our operators. But luckily, they're actually quite easy to be dealt with.
OK, so this is just like a very, very high level of what we're going to end up demoing. Given that there is only so much time here, it's going to be pretty, I guess, basic. So basically, we have Nginx. It'll be running inside of a deployment. Normally, that has its own little web page that's something like welcome to Nginx or something along those lines. But instead, we are basically going to be replacing that. We're going to be using a config map that will be changing what is happening on the screen. It will say hello, and then the Spring part is something that we can pass in. We can have it say something else. And then we'll just basically be going through all of this in a bit. So there's a few things that we end up needing. We need a custom resource definition. Some people just call it a CRD. So basically, that is going to be using YAML. It's going to be specifying how we want this resource that we're going to end up calling a foo to end up looking like. And then also, so Kubernetes actually knows what it even is. Kubernetes already knows what a deployment is. It knows what a replica set is. It does not currently know what this thing called a foo is, or whatever you might have as your own one. So then we also need a controller, since, well, I mean, we've been talking about this for a little bit now. There's also the reconciler, which is where the majority of the logic that is going to actually create the things that we saw will end up happening. We need to have role bindings that basically end up giving permissions to be able to create resources, to be able to see resources, because you can't, unless you have like cluster admin access or things like that, you can't automatically go and do that. And then we also need a deployment to actually be able to go and create to actually be running our controller. So demo time. Questionably.
So it seems the demo gods are not with us today.
Yep. OK, there we go. For some reason, it decided it would not mirror. OK, cool. I'm going to refresh that. All right. OK, so basically, we're going to be starting off with our custom resource definition. So I guess out of curiosity, who here has ever created some sort of custom resource definition? All right, a couple of people. OK, so let's take a look at our foo.yaml. So the kind is a custom resource definition. We have to have some sort of name, just like if you're creating a deployment, a pod, or whatever else it may be. And this basically needs to be some sort of valid DNS subdomain name. So we have our thing called foos, and we have our spring.io, which is also our group for spring.io. We have names. We have our kind. So things, again, you may have seen, whether something is a pod, et cetera. There's what the plural is. There's also a singular. What's the scope? So this one is specific to a namespace. We need to have a specific version. So say if you've seen apps v1, or batch v1 or v2 or whatever it might end up being. There is also an open API v3 schema that you need to use to actually define it. So the one thing that we actually are doing here and actually care about is this thing called a nickname. So when we were seeing the hello and spring, so spring is just the nickname there so that we have something to pass in with our config map. So in order to actually go and create this, you're probably familiar with using kubectl create or apply-f, and then so we can create that. If we do a kubectl get CRDs, we can see our foos.spring.io. Who here has heard of kubectl explain before? No one. OK, cool. All right, so basically, kubectl explain, you can use it on whatever sort of API resource there is to figure out what all the different ones are and where they're located. You can do kubectl space API-resources. So this one, we can do it. You can do it on a foo, and it'll say a bunch of things there. And then you can go in further. You can do it on spec. You can do -- recursive and basically get the entire thing of all the different fields, which can also be helpful for some of the like CCAT exam, et cetera. So we can see that we have one field here, which we already looked at earlier, which is just our nickname. So after we have that created, this is probably the point that you're used to if you're creating a deployment, creating a pod, or whatever else it might be. So this is where we would be going and creating our foo. And then we are just giving it a nickname of Spring. So then we need to be able to go and create that. So right now, Kubernetes knows about the YAML that we have put here, but we actually need to go and do something with Java, because, well, again, this is a Java conference, right? So that's where we're going to end up starting now. OK, so who here has used Spring before? OK, cool. So basically, if you've ever used Spring Boot, which most people have used Spring before, a good place to start is start.spring.io, which is Josh Long's second favorite place on the internet. So basically, we ended up just throwing everything that you pulled down from there. So if you haven't seen it before, you can look at it here. It's the Spring initializer. You can choose whether you want to use Gradle, whether you want to use Maven. There's different dependencies that you can add, and then go and generate your code there, so that way you don't have to do all of that by yourself. So we threw all of that into a zip file, so that way we don't have to go and pull all of that down. So it does most of the stuff for us. We can see that there's dependencies there already, but it doesn't have the one that we need for using it with Kubernetes. There's other dependencies that we could end up using. This is just the basic one with the Java Spring integration and just using the Java client for Kubernetes. And this isn't something that you could, doing things with creating controllers and stuff, it's not just only a Java thing. There's plenty of other languages out there. You may have heard of some of them throughout the day today in other people's talks too. So that's just how you end up adding it for that. All right, so in order for Java we have Java, we have Kubernetes, we have this YAML, but we need to actually be able to model things in Java. We need to actually know how to interact with that. We don't know what a foo is. We don't know what any of these things are. So there is this utility that uses a cluster. It uses kind, and basically it uses the Open API specification. It takes that YAML that we have for our custom resource definition and turns that into Java. So we ended up just downloading all of that instead of actually running it at the current time, because nobody wants to just sit here and watch all of that. You can see that there are a few different models that it ends up creating. We have our v1 foo, our v1 foo spec, and our v1 foo list. So if we go and take a look at our v1 foo Java, you can see, hey, this was auto-generated. And then if we take a look here, we can just see things that we were looking at in our YAML. We can see our API version. We can see kind. We can see that there's a spec. And if we take a look at the v1 spec, we can see that there is just that concept of having a nickname.
So that's all the setup. So it's actually time to create our controller. And for that, it's a MacBook. You have to scroll the other way around.
No, that's because I'm weird and I turned it inverted.
So we'll start by building our controller. So the Kubernetes client that we're using actually gives us access to a controller builder to make things easier. And the first thing our controller gets is something we called a shared informer factory. So now it's a good time to explain what an informer is. So in the cluster, there are multiple controllers always running. And as we just established, it's the controller's job to ask the Kubernetes API, is there anything new that I should handle? You may imagine that if hundreds of controllers are in a while-through loop continuously talking to the Kubernetes API, is there any changes? We're effectively DDoSing our own cluster, which is not great for performance. So instead of that, we have something called an informer, which is basically a cache that is between the Kubernetes API and the controller. So what the informer does is on startup, it tries to get in sync with the cluster, see the current cluster state, and then it will query the Kubernetes API for us and turn what it gets back into more deltas of what happened. In that way, our controller can more work in terms of events, and the informer handles all the other things and make sure that the API of Kubernetes doesn't get DDoSed. So we'll build our controller based on this, this informer. We pass it a reconciler, and we say it's ready to start when the informer is ready with syncing with the cluster. There's some other things, but those are not the important things right now. Once we have controller, it's time to create a bean of type command line runner to actually run the application. So we run it on a single thread executor. We tell the informer to start doing its job, so sync with the cluster and talk to the Kubernetes API. And we tell our controller to run. And of course, Java, we need to add some imports. So let's create our informer. First, before we create an informer, we're actually going to create a specific client. So the library we're using has some Spring integration, and what that means is, in practice, it offers 3 beans. That's about it. That's the Spring integration of this library. But one of them is of type API client. So the API client bean is basically there to just talk to Kubernetes. That's all it does. It has all the configuration needed to talk to Kubernetes. What we do here is we create a specific client. Basically, we wrap the API client to create a client that can specifically talk to a single resource. In our case, we want to talk to something that has the group ID Spring.io, the version 1, and the plural of foods. Basically, exactly the three fields that I talked about before. So this specific client can talk to our specific resource. And we can then create an index informer based on this client. So our informer can only talk to our specific resource. And we create a bean of that, and we'll wire everything together a bit later. And of course, add some imports. And this brings us to the most important bit of our controller, the reconciler. This is the bit that continuously tries to get the cluster in the correct state. So the library we're using already has a reconcile interface, and the only thing it has is one method, reconcile, which takes a request and returns a result. As you can see, the result method accepts a Boolean parameter. And this is a bit of counterintuitive, because the Boolean parameter says if it should reconcile again, which means false is good. As in, if we say false, that means reconciliation over, we're done, the cluster is in the correct state. If we say true, then we basically say, oh, you need to reconcile again. So we basically automatically recall this function. So as I said, the informer is basically just a cache in between. And the request here we're getting is only giving us the fields necessary to uniquely identify the resource we're interested in. So we need to ask the informer to give us the whole resource. Basically, we ask the informer to give us everything that's inside the YAML that we just sent. And for that, we have a listener. That's just a simple way to easily interact with informer. So we get the resource through the listener. So inside the resource, there's everything that was in our YAML that we sent to Kubernetes. Before we do anything, we first have to check if the resource is still there, or if the resource has a deletion timestamp sent. Because if, for example, you create a resource and then instantly delete it, yeah, then the cluster is already in the correct state. Namely, there shouldn't be anything. So we have to make sure that we check for this, otherwise we're doing things that we're not supposed to do. So if we don't need to do anything, we can just return false. As in, reconciliation is over, the cluster is in the correct state right now. And of course, since we use informer, we need to add it to the constructor and add some imports. So then it's time to create our config map. So what we want to do within the reconciler is first create a config map and send it, use the operator chaining pattern, just ask the config map controller to handle that, and then create a deployment and do the same thing. So to create a config map, first we'll create the contents. This is a map having two keys. Index.html, the file name, and in the file index.html, we will set the content to say an h1 hello, and then we get from resource to spec, we get the nickname. So that's a nickname within our YAML. Now we have the content of our config map, we can start building it. So for the foo objects, we had to manually generate code to do that. Because config map is part of the core Kubernetes API, the client we're using is already familiar with this. So we don't need to generate all that stuff. That's all part of the client. And it has some nice builders that allow you to easily configure these things. And this is exactly the same as writing YAML, but using a builder pattern. As you can see, we have a config map. We have to specify the API version. We apply the metadata. And we set an owner reference. That's basically what I talked about. Every resource should have an owner. And we then set the data, and then we can build our config map. To create an owner reference, we do basically the same thing. We just use the inbuilt owner reference from the library, and we set all the properties. That's basically exactly the same as the config map. And we add the imports, we import the models from the client. Then we're going to apply the config map. Basically say, Kubernetes, please install the config map. But before you do that, we first need to do a try-catch. Because something can go wrong when applying the config map. Like we could have network issues, or Kubernetes API had a hiccup or anything. Like stuff can go wrong. And when stuff goes wrong, well, first we're gonna log this. And then we can return the new result, now returning true. Something went wrong, so we need to reconcile again. To prevent that from instantly happening, we can also give a duration, as in wait at least 10 seconds. Like services can get up again, network issues can be fixed again. So we give it 10 seconds, and then we just go into the same loop again. Then we need to create our config map. But just like I created a specific client for the Informer, we also need to create a specific client to handle config maps. So for that, we need to know the group the config map is in. So we can just do a kubectl API resources grab config map, and we see v1 here. So it doesn't actually have a group. But that's because it's part of the core of Kubernetes. So we need an API client that can talk to the core group. Luckily, there's already core v1 API, part of the library that we're using, because it's core, it knows about Kubernetes. So we'll go into how we create that one in a second. For now, we'll just wire it to our constructor. And now we can start applying the config map to Kubernetes. So first thing we do is we check if the config map already exists. For this, we'll do it in just a quick and dirty way. We just list all the config maps within the namespace. If any name match, then it already exists. If not, then it doesn't exist. So if it exists, we don't want to create a new one, we want to replace the current one. And otherwise, we can create a new one. These are, again, just REST calls. So the equivalent is this is just a put operation, and this is just a post operation. So it's very important that we do the config map exist check here. Why is that? The reconciliation loop can go over multiple times. For example, if something if the deployment fails, then it will reconcile again. Now it comes back to the config map. If we don't check if it exists yet, it will try to create a new one when one already exists, and then it will throw an exception. So what happens then? We go back into reconciliation, which tries to create a config map, which already exists, which throws an exception, which goes back into reconciliation, as in we're creating an infinite loop. And that's typically not a good thing to do. So all these things that we do within a controller have to be repeatable. So all the steps you do have to be repeatable, because it's very, very reasonable that you go into the reconciliation loop multiple times. So once we have this, we add the API exception, and then it's time to create our deployment. So here we do exactly the same thing. We try to create the deployment, and if anything fails, we reconcile again with a duration again of 10 seconds. So there's also a builder for the deployment here, but as you may know, deployment it's quite a large file. So instead, we'll cheat a bit, and we'll just use some YAML templating. So we have a template of a deployment descriptor. Here we see the API version that it's an apps group of type v1, the kind is deployment, and we have some placeholders for the name and for the namespace. So we're saying we want to have 2 replicas. The container is of Nginx, and we'll take the latest image of Nginx. So let's hope they didn't update it to something that doesn't work in the last hour or so. We'll set it to be container port 80. And this is the important part. Here we map the volume to our config map. So this way, the default index.html is replaced by the index.html within our config map. So then the only thing we have to do is we load our deployment templates from the file system. Just load it from a class path. Well, we could do some fancy templating engine stuff. Instead of that, we'll just do a replace all namespace and a replace all name. That also works. And then we load the YAML into an object, like the v1 deployment. This is also a tooling that you automatically get within the library. So you already have access to all of that. So now we need to send the deployment config to Kubernetes. So again, we may need a special client for this, because if you look at the group deployment is in, as we just saw, it's an app group. So we need to have a special client for the apps group. Luckily, we can do that. That's also already part of the library, so we'll inject it here. And then it's time to create the deployment for Kubernetes, to send to Kubernetes. And here we see exactly the same thing as the config map. First, we check if it exists by just listing all deployments within the namespace. If the name is equal, then it already exists. Then we replace it, and otherwise we create it. Again, repeatable steps. And then we add some imports. So if we look at the full code, what we're doing here, as you can see, this is a relatively simple controller, but that's what most controllers are. They don't have to be that difficult. The only things we have to do is get a resource from the informer. We create our content map, or we create our config map, send it to the Kubernetes API. We create a deployment, send it to the Kubernetes API, and just then say, oh, we're done with reconciliation. This is all our controller have to be. So controllers can actually be very, very simple. There are also some frameworks out there that can help you with creating operators. For example, there's Operator Framework, and there are a few others. But for here, we decided to just use the Kubernetes client, because this is the most simple way, the most basic native way to do it, just to show you that building controllers actually isn't that difficult. So once we created everything, the only thing we still have to do is create some beans for the apps1v API and the core-v1 API. Luckily, this is very easy. They're just wrappers around the API client, just as we did with creating the shared informer client. So we can just create beans of those. And then we can create a bean of type reconciler, where we just create a new instance of a reconciler, and we pass these three things. And then we should have a working controller. After, of course, we do some imports.
Okay, so I guess still on. Testing.
Ah,
I guess, yes.
Turning it off and on again.
Exactly.
Yeah.
All right. Okay. So we have a bunch of, we have our, hello. Testing. Okay. Cool. That sort of works. Okay. So we have our YAML. We have a bunch of Java, but we still don't actually have our app running in Kubernetes. So a lot of you, if you've been using Kubernetes before, at some point in time, you had to deal with a Docker file. So going and being like, here is a base image I want, and here are the different things that I want to go and install, and just figuring out all of those different things there. There's another option if you want to, so you can use cloud native build packs. Who here has heard of those before? One person. Okay, cool. So basically, it goes and looks at your code and determines based on what language is being used there, what build packs to end up using. And it will end up actually creating a container image for you from your code. I'm not going to actually go and run that right now, but you can use, if you're using Spring Boot, it's built in with Maven or Gradle, and there's a command that you can basically run that goes and creates your image. And again, not running that because, well, internet. So if I go and look at Docker images, since this has already been run earlier, we can go and we can see that it was created 44 years ago, of course. And so the next thing we need to do is actually go and push that up to a registry, because if you are using Kubernetes, then it needs to be able to pull your container image from somewhere. So luckily, the internet is actually working. Things are pushing up. And then if we go look here at this file, our controller deployment.yaml. This is what we were talking about a bit earlier. We need to have role-based access control. We need to be able to look at our foo. We need to be able to do a get. We need to be able to do a list. We need to be able to look at a deployment and be able to also look at config maps, since those are the different resources that we have in this. We need to end up having a cluster role binding that ends up connecting our cluster role to our service account. And with the cluster role, it's being able to see it in all the namespaces. Then we have our deployment, which is just our foo controller. It uses that image that we just pushed up to our registry. And then we need to go and use kubectl to go and run that. So if we just wait a tiny bit of time, if we do a kubectl get, we are doing a kubectl get on our foos. We're doing it on config map and also on a deployment. So if we look here, we can see that we have my first foo. We can see that we have our config map for my first foo. And then we can also see that we have our deployment as well. So right now, none of you can actually go and do anything with this. You can't see it. It's just running on this cluster. And in order to be able to have anyone be able to access that, you need to have a service. So for the way that this one is working, so we're just going to use kubectl expose to create our service. And it's using an ingress controller and using this like workshop port. So basically this whole setup here is this thing called educates that VMware created. It's open source. You can create your own thing like this as well. So if we go and expose it, so then we can actually go to this link that we actually can see what we ended up creating. So if we go and click on that, we can just see what we were showing in our screenshot earlier that basically just says, hello, Spring. So a lot of code in a way, and some YAML to be able to just go and create something like that. But that's a base that you can start with for any other type of controller that you want to end up creating. So if we try going back over to PowerPoint. OK, so yeah, we saw all of those different things created. We saw our foo. We saw that we created a deployment. We created a config map. We have pods running, and basically being able to go and see that page. So if you want to go and look at all of the code that was in this whole thing, if you go to that QR code, you can do that. If you want to look at us on LinkedIn or whatever else, there is the QR code up there. This talk has gone through several revisions and various people helping on different things over time. So special thanks to Josh Long and Timo Salm. So yeah, thank you very much.